Hello, my name is Aarini Panzade, and my research is about the effect of TIMP1 levels, MMP1 levels, and healing times on the wound surface area. Diabetic foot ulcers are a major health problem in the world because they're the leading cause of non-traumatic amputations in developing countries. There are two types of important enzymes that affect the wound healing process in diabetic foot ulcers, MMPs and TIMPs. MMPs are enzymes that degrade all kinds of EM, or extracellular matrix proteins, and therefore they are a key element in the wound healing process. TIMPs are a tissue inhibitor of MMPs, meaning they're an important physiological inhibitor of ECM metalloproteinase. The objective of this research is to create a multilinear regression model to describe the effects of MMPs, TIMPs, and healing times on the wound surface area. The data that was used for this research came from a previous study. This study determined if different types of MMPs and TIMPs would affect the wound healing process or not. In this study, 16 different patients were used in a 12-week period to analyze if the enzymes affected the wound healing process or not. The results of the study were analyzed for the degree of wound healing, poor healers and good healers. The conclusions to the study were that a high level of MMP enzymes are important to the wound healing process, whereas too much of MMP8 and MMP9 is harmful for the wound healing process, although the ratio of MMP and TIMP is a predictor in the process. To create my multilinear regression model, I first imported all of the modules of Python and the dataset. Then the data was cleaned by checking if there were any null values, and if there were, they were removed. Next, 80% of the data was split into the training set and 20% into the testing set. After that, the model was trained and the coefficients of the three attributes were found. Next, prediction on the test data was done to check the difference between the actual value and the predicted value for the model. Then, we plotted the prediction data for the three attributes and evaluated the performance of the algorithm. This is the code where first I imported my data, and then I used the pandas data structure in Python to import it. And this is just the data file. And then this part is my actual linear regression model, which I created for the three different variables. But this is just an example for temp levels and weeks versus surface area. And then after I graphed this using this code right here, by using the x label, y label, z label, and then the plot surface function, I could use this to graph the temp levels and the weeks versus the surface area. The coefficient for the MMP levels were 0.08841. For the TIMs, it was 0.185095. And for the weeks, it was negative 0.101787. From this table, you can conclude that for the weeks, the surface area was decreasing by that coefficient. This is the graph for MMPs and TIMs, time versus surface area. This is the graph for TIMs and time versus surface area. And this is the graph for MMPs and TIMs versus surface area. From these graphs, it can be concluded that TIMs and times affected most on the surface area because the predicted points for this graph are the most spread out of the three graphs. There were three model errors for this model. The mean absolute model error was 2.226% for the overall model, which is considered good if less than 10%. The mean squared error was 8.4757% for the difference between the actual value and the predicted value. The root mean squared error was 2.9113% for measuring the error for quantitative data. To continue this project in the future, I would create a user interactive program where the user would be able to type in MMP1 level, TIMP1 level, and the week number, and then it would predict the wound surface area given those variables. Thank you.